Hey Tom, I had a customer call me recently that was expecting strain levels on a plastic up to about 10% strain. And he was looking for recommendations. So I'm looking for recommendations from you. What would you suggest to a customer looking for strain measurements up to 10%?
Well, the first thing they'd have to look at is the EP series of gauge, and the P stands for post yield or high elongation studies. That particular gauge, when properly installed, is capable of getting up to 20% strain under the perfect circumstances. The other thing you have to consider is the adhesive itself. Now, we have some adhesives like AE10, AE15 that around room temperature are good for between 9 and 10% strain. But if you're truly going to go to ultimate failure, where you're going to go one piece is going to make two pieces, then you probably ought to look at the A-12 adhesive. That adhesive system is designed specifically for high elongation measurements. And if you use it properly, it's properly cured, you could conceivably get up to 20% strain. Take a part that's 10 inches long and make it 12 inches long.
That's a great point. And this Embond A12, how do you go about curing it? Does it cure at room temperature?
It can cure at room temperature, but you're going to be disappointed by the time reference. It's going to
Oh,
be
oh
two
no.
weeks.
Oh, two
Okay.
weeks.
If you cure it at about 175 degrees Fahrenheit, it takes a couple hours. Look at the spec sheet for the adhesive and follow the instructions carefully. If you don't follow the instructions, remember what your mom said: if you don't do what I tell you, you're going to be in trouble. If you don't follow the instructions, you're going to be in trouble.
So would you, with the Embond A12 and the EP series gauges, you said the EPs were an annealed foil, a soft foil that can take a high elongation?
It's the Constantan that we've made dead soft. That's why you only get one STC. You get an '08, or you can get an '08, or you can get an '08. That heat treatment process is how we set the STC. So you'll have an '08 at compensation, but generally when you're measuring 200,000 microstrain, you're not too worried about a couple of hundred microstrain of thermal output.
What about connections to the strain gauge? Do you run the wires directly to it, or do you typically have a transition point? How do you normally do that?
Well, for high elongation, you have to have enough strain relief so that the wires themselves will flex appropriately. So you put a separate bondable terminal just adjacent to the gauge, and then forming a U shape coming in at 90 degrees to the long axis of the gauge or its sensitive direction, you eliminate or limit the amount of stress that's going to be on that solder junction there also. Another thing to be considered when you're doing high elongation measurements is the surface itself. Now, normally when you're putting a regular strain gauge down for generally 6,000 microstrain of strain, the surface can be fairly smooth. But the higher you go in elongation, the rougher the surface has to be so that the adhesive has something to grab hold of. You might actually take 80 grit silicon carbide abrasive paper and crosshatch it, which under normal circumstances you'd say, wait, that's way too rough. But in a high elongation situation, if you don't have that ability to bite to the surface, then you will not get the elongation that the adhesive and gauge are possibly capable of.
Gotcha. What about if an application were to exceed? I think we said that the combination of EP gauges and A12 can go up to 20%. But what if a customer had an application that they expected to go beyond that? Some type of softer material, pulling it to its limits. What would you suggest for that?
We'd probably go to something what we like to call a clip gauge. Basically, it's a hat section where we bond two gauges on the top, two gauges on the bottom, and as the two legs separate from one another, that puts two of those gauges into tension and two into compression, and then you calibrate it. You basically pull at a known displacement or known elongation, and you calibrate that in terms of that elongation. And that way you can get much higher elongations without the reinforcing effect of bonding a strain gauge. There are some companies that make extensometers that can be used in this
Okay,
application too, if you want to buy one rather than build it.
understood. So if that customer wanted to read more about high elongation strain gauge measurements, what would you suggest?
Well, we have a tech tip 605, which is on our website. And in that tech tip, it goes through all of these steps and all the gauge selection, the surface preparation, adhesive selection, all of the things that will make you successful if you're trying to make an ultra high elongation measurement.
Fantastic. Cool. Thank you.
You're welcome, Daryl.